Welcome back, everyone, and we are on video number 4, I believe. The whole idea here is to be able to put together this power supply that comes in a kit, which is part of your projects. Here, the stage we're in is actually assembling the parts. And pardon me, I actually skipped something which is not terribly critical. What I did is I jumped over to page number 4, right? So I did page number 4 instead of 3, but that's okay. You actually can alternate that, because what I did is I went ahead and did the PC wiring on the board, and then I'm going to go back and put the components. All right, I should have put the components and then put the wires. It really doesn't matter. It's not that critical at this time. It's not that I exchange parts or put parts in the wrong place. It's only the process that I, again, went to do the wiring instead of doing the parts. No problem. You got a handle on the thing here. And so now I actually have 2 cameras. I have this one right here, which is showing you details, and the other one which is showing you details from the other side. Hopefully we're going to be able to assemble this starting on video number 6, so you can have a great idea how this is going. So I have not soldered the components yet. I've only placed them in place, right? So there's the components. And once again, verify that the components are according to the graphic on the assembly manuals. You want to make sure that that's the case, because otherwise undoing and redoing is a little more complicated than doing it right. And most of these components are polarized, meaning there is a right and wrong position to put those components. So they're all in place. And what I'll do is I'm gonna twist it over here, and you can see all the components in place right there. I don't know how I'm gonna be able to hold this guy, but I'll do my best. All right, and hopefully be able to show you both sides. Having put all the components like that and getting ready to solder them, this works okay. You can also place component by component and solder them individually. The trick here is, as I said before, to not just dwell on a portion of your board, because you could destroy it with heat and thermal shock and mechanical stress. And so you want to jump back and forth between components. For instance, I would probably do one component here, then I'm going to go to the other extreme, and then back here, and then back here, so that I can alternate. While heat dissipates, then the board will not be put under extreme stress, okay? So there's no particular order to solder this component, as long as you do it right. I think that's the key concept. I'm seeing some holes that are freeheld, but those are going to be for the special purpose power transistors that we have. Actually, those are the transistors that allow the power supply to be adjustable. So those are the IC317 type of transistors that we're going to put in place there carefully, so that our power supplies will do its work. For the time being, I'm going to just concentrate on getting everything that I have in place soldered. My light is not terribly good, but I'll do my best, and then we'll do a little quality control as we go. So once again, I'm using solder paste or flux. Did I say solder paste? Sorry. Flux as a way to clean up and prepare the eyelets and make good connections. It's always a good practice to put flux here, so that everything is clean and the heat is nicely transferred. So far, so good. We've done a good work, and so we are ready to do more work. And hopefully my soldering station is ready to go. And here we go again, reviewing the concept. You basically have 3 pieces: the workpiece, the solder tip, and the solder. And then you basically do a joint, put the solder tip on the eyelet, come down with the solder, melt it, count 1, 2, 3, and that should do it, right? Yep. So that's the power resistor. And I'm gonna go back to the other side. Try to solder the individual components. In other words, focus on doing the solder on both joints or 3 joints of a component instead of just jumping back and forth. So here I have that one. I'm gonna come back here to do these resistors in here. So here I go. You may not be able to see the whole thing from one side, but you got it on the other side. So there is that one. And once again, the care you want to have is don't create unnecessary bridges, right, or unnecessary joints. That's really my point here. Just solder what you need. I'm gonna quietly do this part, okay? You just show what you just see what I'm doing, and do your work. So I'm actually alternating and between one place and the other. We should have good joints. Everything has been prepped, so I can go another side here. Hopefully our video is capturing this good demonstration. And once again, the idea is to put the parts where they belong. And so if we get those parts where they belong, then we'll be in good shape. No problem, everything's gonna be all right. Okay. Have I forgot anything? Well, you saw me doing it, and once again, follow the assembly instructions. You should be good. If you do that, do some really solid solder joints. That's what we need. And as you see me, I've been going back and forth so that the heat is not just concentrated on one area, but it's distributed evenly so that the board itself doesn't suffer any damage. You don't have to hammer this board. This is a kind of delicate piece of equipment, and so the solder joints are done gently but solidly. And once again, here I go. I'm jumping back and forth with the idea of making time so that the solder that I did cools down while I go to the next side and do the other one. A little bit of smoke here, but nothing too bad. You probably don't want to be doing this in a confined space if you were to do this in a permanent basis, okay? You want to be careful with this. All right, we're going to start trimming out. Perhaps one of the most delicate components that we have here is the transistor, this one right here. The 3-legged component. It's easy to do bridges on that one, and I'm going to leave that for last so that I can carefully solder that transistor, okay? My soldering gun is doing really good. Sometimes you can battle with the solder tip and not have a good joint. But the secret to a good solder joint is really a clean tip, proper temperature, proper tools, and so on and so forth. And you already see me prepping and doing this work. So you should have a pretty good idea. And you're seeing the demo. You can go back and review these videos if you wish. But I've done quite a few projects like this, and I found always very useful to record myself as I go, even when I make mistakes, right? I give you examples of what not to do, right? In this case, all is going good, and hopefully we'll come to a point of test where this power supply will work as it is intended to work. All right, so that will be. Can we pause that video? Just pause, not stop. Don't stop it. It's okay. We're gonna go ahead and go to the end. Okay. I think I have a pause feature in there, but I forgot where I have it. Okay, so the idea once again is to be able to alternate those solder joints as you do your solder. Okay, cover the eyelet, make a solid joint, let everything be in place. Remember those polarized components, they have to be put right and soldered right, otherwise you may end up with troubles. And undoing and redoing is a little harder than doing it right from the first time. We know that. One more joint down below here. Nicely done. Couple of joints in here. When you have very close joints, you really want to be careful. Now, in this particular case here, I think this is not a problem. When you have eyelets that are tied together, that means it's okay to bridge them. But if you have eyelets like this guy right here, which are separate eyelets, then you really need to make sure that they're separate. So in this case, I think I'll be okay here. No problem. It's kind of an eyelet that got together. All right, doing good so far. And hopefully I have plenty of solder so that I can do the job towards the end or until the end. So I'm still alternating back and forth, right? Because I don't want to concentrate the heat just on what part of the board. I want that heat to be evenly distributed and the stress on the board itself also, so that it doesn't suffer any damage, right? That's the idea. No damage to the board. That's your goal. And hopefully have a functional piece of equipment, which is our goal too. Pretty nice. Can't complain. We got good equipment, brand new parts, and it's all working just fine. I got just that eyelet right there, which I need. I mean the transistor legs or solder joints, which really need to be done right. I'm gonna twist the board a little bit so that I have a better angle for that, because this one needs to be done right, and I need to be able to see what I'm putting my solder tip. This is the transistor, general purpose transistor. Nonetheless, we don't need to bridge this guy. If you see real careful right there, I don't know if you can see it or not, but it is 3 distinct and separate eyelets for the transistor. That has to be done that way. If you bridge that, then we'll be in trouble. So let me see if I can do this here. Hopefully this side will gather it. But you know what I'm saying. I should be able to do a little close up on that one. Okay, so that's a better shot. Yeah, you can probably see that. So I'm going to be very careful on that one, because I don't want to joint those points in there. They have to be done right. No bridges in there. If we bridge them, we'll be in trouble. And so I'm going to start soldering the lower part very carefully. I could actually use a thinner tip to do this work, but I'm going to trust my experience a little bit here. Hopefully we'll do right. And so I'm going to solder the lower leg. You guys see that one? Okay, then I'm going to go to the upper side very carefully. Ah, beautiful. And then I'm just missing one spot, the center spot. Once again, this is probably one of the delicate parts you need to do, and make sure you do right. I hope I did not bridge that. If I bridge that, I'm gonna have to redo the work. Okay, and it's probably a good opportunity to show you how you undo that. I think I did bridge that. Yeah, there is a bridge between the center and the left hand side, so I will have to rework that out. Good opportunity for you to see how this work is done. Okay, so there is solder. There's a bridge in between the two legs, and we don't want that. Okay, that's not a good practice. So I'm gonna have to undo that. And I see a couple of joints here that need a little work. All right, so I'm inspecting it with kind of a magnifying glass here. And all right, I will show you here in a little bit what we need to do. Here is a solder wick. We call this solder wick. And what this is a way to remove excess of solder from the board. And the way I use these, you can cut a little piece. All right, you can cut a little piece and use that little piece. I also like to use flux with this. So I'm gonna flux this out, put flux on it, because I want to remove the excess of solder. I remove the excess of solder right there. Otherwise, I'll be in trouble. So forgive me. I need some helping hand here. And what I try to do is remove that solder from that spot right there, if we can. And so I'm being challenged with this. Hopefully I can do this. I believe I can. And I did it. You see that? I have removed the solder joint, the unwanted solder joint, and I'm going to go back and reflow that by placing solder right at that joint and making sure it stays isolated. That is something you don't want solder. I think I'm struggling a little bit with the magnifying glass. It's such a tiny surface right there. So let's see if we can do a little touch-up work there. There we go. I think I've done that. And hopefully it is removed. So we're going to stop here the video, and if there is a need to touch up, I'm going to go ahead and touch that up, okay?